Okay, so first of all, we'll look at the area of this triangle with side lengths of 3 and 4. Now you'll notice that the height on this triangle is actually the same as the side length because it's a right triangle with the right angle at one of the vertices. So we will take a half times the base times the height of 4. Now in my mind, I would use the commutative property to switch the 3 and the 4. So I could take a half of 4 is 2, and 2 times 3 is 6. So our area is 6 square meters. Now, to get the perimeter, we need all 3 side lengths. So the question is, what is this third side length? Since we have a right triangle, we can use the Pythagorean theorem to find that third side length. So we can look at Pythagorean theorem, a squared plus b squared equals c squared, where a, b, and c are the side lengths of a right triangle. So we'll put in 3 squared plus 4 squared equals c squared. So we have 9 plus 16 is equal to c squared. 25 is equal to c squared. So we need to think what number squared is 25, and that would be 5 or negative 5, but since we're talking about a length, we'll just ignore the negative 5. So we've got a side length here of 5 meters. Okay, now we can find the perimeter. We take 3 plus 4 plus 5. We have 12 meters. To the first power would be the perimeter. Now, the nice thing about the Pythagorean theorem is you can find a side length, or you can also look at any given 3 side lengths and figure out if it's a right triangle. If it fits the Pythagorean theorem and makes it true, you know it is a right triangle. So I'll give an example and you tell me if it's a right triangle. Let's say you have side lengths of 15, 20, and 25. Will those side lengths make a right triangle? Good. Okay, so if we look at possible side lengths of a triangle, 15, 20, and 25, we can tell if this is a right triangle by plugging in them into the Pythagorean theorem and see if it comes out true. So 15 squared is 225, 20 squared is 400, 25 squared is 625. So let's just type this into Desmos. 225 plus 400 is in fact 625. So we would say this is equal, and therefore these side lengths would form a right triangle. So the answer would be yes.